All right, in this video, we're going to use synthetic division to try to find a root of our given polynomial. You can see I have an outline of the method. It's pretty detailed, but if you're new to synthetic division, I think it's really helpful to have this by your side as you are completing synthetic division. Once you do a couple of examples, you will probably not need this. It'll just become second nature. So before we jump into the synthetic division, let's go ahead and review how to find our list of possible rational roots. This is the Rational Roots Theorem, and we use that P over Q. So remember, P is simply your constant term, and we want to list out all the factors of P, both positive and negative. So for 6, we have 1 times 6, so positive and negative of both of those, because 1 times 6 is 6. We also have 2 and 3. Okay, positive and negative of those. All right, so then our Q is our leading coefficient. It's our 2 here. And the factors of 2, of course, are just plus or minus 1 and plus or minus 2. So to make our list of P over Q, or possible rational roots, we want to take each of the P's and put them over each of the Q's. So it'll be easy enough when we put them over the plus or minus 1 because it'll just be our list of P. So let's go ahead and just list those out. Plus or minus 1, 2, 3, and 6. And then when we put each of those P's over our second factor of Q, 2, we do add plus or minus 1 over 2. We know 2 over 2 gives us 1. We already have that here, so we don't need to list it again. 3 over 2, so plus or minus 3 halves. And then 6 over 2, we already have that on our list. It's the plus or minus 3. So again, this is the list of all your possible rational roots, and we're going to test one of our linear roots here to see if it's a root of our polynomial. All right, for this example, let's start with positive 1 as our root, and we are moving into now this method, so we're going to prep row 1 as our first step, box our test root, positive 1, and then we're going to list our coefficients from our polynomial. Make sure you check the sign, and then if you did skip a term, like say there wasn't an x squared term, you would need to put a 0 as a placeholder. That's what this means here. All right, but that is not our case here. We have a 2 as our x cubed coefficient, a negative 1 as the x squared, a negative 7 as the x, and a 6 as the constant. All right, so this is our setup, and we are ready now to actually do synthetic division. So we initiate by bringing down our leading coefficient, recording it in row 3. And now we're going to multiply our root times our row 3 coefficient. So 1 times 2, and record that in row 2 of the next column over. Then you add that second column, so negative 1 plus 2, that's positive 1. And then you're just going to repeat this process until you reach the end of your setup. So we have 1 times 1, of course, is 1. We add this column, negative 7 plus 1 is negative 6. Repeat, 1 times negative 6 is negative 6. We add, and we see here we have a remainder of 0. So looking at our analysis section, if our remainder is 0, we have a root of the polynomial. Remember, root is just another name for x-intercept or 0. Right, we can write this as a point on the graph. Remember, it's always the root is the x-coordinate, the remainder is the y, so there's that point, that x-intercept on our graph, 1, 0. And what's great is now we can write our polynomial in a more factored form. So this is really good, yes, if you're asked to factor a polynomial, but it's also really helpful for graphing because then you can find your roots or your x-intercepts. It makes it much easier to graph. Okay, so here's how you kind of decipher that information. You'll always have your root. You need to put it back into its factored form. So this will be x minus 1. Think set that equal to 0. You would solve for x equals 1. Okay, and then you'll get the other part of the factored polynomial working backward from your remainder on row 3. So the negative 6 will be your constant term. The 1 will be the coefficient of your x term. And the 2 will be the coefficient of your x squared term. Okay, so we can rewrite this. I'm going to write it down here. This polynomial using our x minus 1. So we have y equals x minus 1. And then we have 2x squared plus 1x minus 6. Now that we have it partially factored, so it's a binomial, a linear binomial, and then a quadratic trinomial, you can try traditional factoring, or if that didn't work, you could use the quadratic formula on that quadratic to get the other two roots for this polynomial. So let's try traditional factoring here just to see. All right, we keep that binomial here. Okay, let's separate it into 2x and x. We need factors of -6. So let's try a -3 and a +2, and let's make sure our outer and inner give us back that +1x. So we have +4x minus 3x. It looks like that checks out, and so we can see our other two roots. We have them in factored form, so we would see it would be 2x minus 3 gives +3/2, and x plus 2 gives -2. So those are all your roots of this polynomial. A cool thing to do, since these are all rational roots, is to look back at your P over Q list, and you can see that all three of these, so 1, 3/2, and -2, were on our P over Q list, our list of rational roots that were possible. So hopefully this gave you a good review of that rational roots theorem and also helped you really practice that synthetic division method. So keep practicing. Like I said, it will become second nature, and it's such a great tool when you're working with polynomials. Thanks for watching, and good luck with your synthetic division.